Well, good afternoon, everyone. Thank you for joining us for the part 4 of our 4-part series, Thin Overlay, In-Place Recycling and Reclamation. Just want to give you a brief overview of what we do for the Missouri Missouri Center for Pavement Preservation seminar. Sorry, I'm not feeling too good today, but so what we did is there's 4 founding members. There's me, 1 from Missouri Petroleum, 2 is Brett and Caitlin with microsurfacing, Sean Brost with Vance Brothers, and Jack Whitty with Corrective Asphalt Materials. And the main reason we put this together is so we could explore and let other people find out about the benefits of pavement preservation through training, through education, and we wanted to transfer that between the academia, industry, and other agencies. So that's why we put that together. I'm going to introduce our presenters today. Chris Evers, he is the executive coordinator with the Florida Pavement Preservation Council, and then also Larry Galehouse. He's the founder and director of the National Center for Pavement Preservation. So, Chris.
Good afternoon. Actually, we're going to start with Larry. I will kick it over to my compadre. No, that's okay. It's not a worry. I appreciate it, Mike. Here's our outline, and Larry, I'll kick it over to you, and then everyone will just have a real pleasure when we get to the treatments part. So I'll check in then.
Okay, well, thanks, Chris, and good afternoon, everybody. It's my pleasure to talk with you this afternoon, and before we get rolling too far, I just want to talk about a couple things here that really are important. And let's talk about workmanship, because workmanship is going to make or break your treatments. This is the cause of poor pavement performance all across the country. And you can see by the colors, and I'll point them out, most of the causes of poor pavement performance have to do with workmanship. 66%. Everybody says, oh, it's a problem with the materials, whether it's the oil or the rock, you know. That's only a 9% of the issue, and these are only the problem pavements. Design, you know, it was a poor design. Well, that's a little worse, 21%, and then we have a sliver that we're not even going to show, and that's natural disasters. That would be like fires and floods and so forth that just destroy our pavements. But workmanship is the key. I mean, and we're going to go through and just show you a couple examples, because we can talk about this all day long, but if we're not getting good workmanship out on the job, we're going to have a problem. This is an example of poor chip seals, unacceptable. You can see that probably the aggregate was dirty. Maybe they didn't sweep it properly. Maybe the emulsion began to break before they actually got the stone embedded. Maybe they didn't roll it properly, but these are all problems. This is what a chip seal should look like. And I want you to think about this for a moment. A chip seal is made out of oil and rock. My gosh, isn't that what hot mix is made out of? And if you can't make a chip seal look like a hot mix, you're doing something wrong. And we owe it to the public to give them a road that doesn't have loose stone, that looks good, and it's going to last a long time. And if we're doing a chip seal properly, this is what we get. Let's move into workmanship that's unacceptable with microsurfacing. You can see the chatter, or the little chatter bumps in it. You can see a joint. It's not a good microsurfacing. And this really is unacceptable. Microsurfacing, we can put it down, open it up to traffic within an hour's time in most cases. And a microsurface will wear just for years. So it's a very, very good product, but it's unacceptable if the workmanship isn't there. This is a interstate in Kentucky with a microsurface, and it really looks great. It's going to last a long time. So the point I'm trying to make here is the best treatment designs and materials are of no value without good construction workmanship. And what's the key to construction workmanship? It's a quality assurance program. And Chris and I can talk about this for a long time, but quality assurance is not only quality control from the contractor, it's quality acceptance by you, the agency person, and then it should have some sort of independent assurance along with it to make sure the tests are done right and things are calibrated properly. So this is one of the keys. And if we have a good quality assurance program, we're not going to have a problem. Both the agency and the contractor take responsibilities for the project. And so quality assurance is the key. Now, let me jump ahead into one other portion. And this is talking about specifications. And this is where your input is important. And we have a polling question. And Christy, if you could put that up. And the polling question is, where would you likely find a good pavement preservation treatment specification? And only give us one choice, one single choice. And we're going to give you about another few seconds. Okay, got a few more. We can wrap it up in a couple seconds. Okay, well, it's kind of interesting because everybody looks in different places. We had one group say local agencies. We had 6 groups say state agency. We had 6 say AASHTO. It's kind of a smattering, one saying the contractor and then the other saying other organizations like, the Florida Preservation Council, NCPP, the Pavement Preservation Resource Centers, and so forth. So it's a smattering. And that's kind of interesting to know. But let's move ahead, because I want to talk about the importance of specifications. And I think that that's something we need to talk about before Chris gets into it. I'm going to talk about AASHTO specs. And why are AASHTO specs important? AASHTO specs just aren't thrown together by 1 or 2 people. AASHTO specs, first of all, we have an emulsion task force that are developing pavement preservation specifications. And the development time to write a spec is in the neighborhood of 1 to 2 years. And why does it take so long? Because there's so many nuances to a spec. The formats are very important to submit to AASHTO, but also the materials. And you've got to get a consensus from all parts of the country to put the material specs or the design specs or the construction specs together. And it goes through a long process. I'm not going to go through this, but what I want to show you is at the end, when it's adopted, it's a provisional standard. And it usually takes 1 to 2 years for the approval process. So it takes anywhere from 2 to 4 years to get a single specification approved by AASHTO. And that's why I like AASHTO specs, and that's why I want to talk about them, because they are really important. They have their own referencing system. If you want to get a spec from AASHTO, you'll have to pay for it. They're in the neighborhood of about $35, something of that. Some are a little more, some are a little less. But they have various codes. The P at the end of each one of these means a provisional standard, and provisional standards are there for a while until they become a full standard. They become a full standard when people begin to really use them. So that's just a little bit for your information. Now, I'd like to have you write this address down, because I'm going to give you a whole bunch of ways you can get an AASHTO spec at no cost. So http:// TSP2-ETF.org. I'll give you just a second to write that down. And that's going to take you to a web page. And this is the web page. It's put together by the Emulsion Task Force. This is a outgrowth of the AASHTO TSP2 program. And when you get into the web page, you're going to see specs, checklists, and best practices. And this is just a screenshot of what you'll see when you get into the website. First thing you'll come across are all the checklists. Now, these are just the asphalt emulsion treatment checklists. And the National Center, we wrote these back in 2019 for Federal Highway, and Federal Highway has since published them all. And if you're out on a job and you don't know exactly what to look for, these are going to tell you. It's a step-by-step of how you build a job, not as a contractor, but as an agency person, how you build, how you inspect the job. So these are good resources for you. Also on that front page, web page, if you look in the specifications, these are all of the specifications that have been submitted to AASHTO for approval, and they have been approved. But if you open these up, they'll say draft on them or working draft. The idea is that these were submitted to AASHTO for approval, and these are the working guides. Now, the only difference between these and the approved specs is probably a little bit of formatting or a little language change, but as far as the technical information, there is absolutely no change between the technical information in these and what the AASHTO spec is. So this is a way that you can get the specs. Now, these are the draft construction specs up here, and they call them guides, but they go for the emulsified chip seal and a hot applied chip seal, micro surfacing, and the emulsion, asphalt emulsion fog seal. This is going to tell you what is the major changes in these construction guides. And then these are going to be your design specifications, how you design a chip seal, how you design a full depth reclamation. All of these are here. The draft specs, these are for materials. They're all here. And then the quality assurance guides, right now, we only have 2 that have been written and approved, but these are for chip seals and slurry. Slurry systems involve micro surfacing, slurry seals, and polymer modified slurries, just for your information. Okay, moving ahead. There's also been some revisions in asphalt emulsions, and these have been approved by AASHTO as well. Asphalt emulsions are in a continuous state of change, you might say, and these have to be updated. So these are revisions to the existing emulsion specs. So in your specification, for example, for a chip seal, it's going to reference M316, and 16 is the year that it was approved. But these are things just to be aware of, that you've got to specify the current specifications. These are the checklists that you'll also see on that web page. So you don't need this long address. You can just go with the one I asked you to write down, but it really is your step-by-step process to go out and inspect a job and know what you're looking for. If you want to get into more treatments, Federal Highway has the checklists on their website too. So it's the technical preservation checklists, and they have them for concrete as well. So that's a real quick run through. I want to give time to Chris because he's got some real good stuff. And Chris, if you want to take over from here, I'm going to stop sharing.
I do want to take over, and there we go. Hopefully everyone can see that. You just saw our introduction to the module 4 here, part 4, and we're going to dive right in. And what are we covering? Well, here's what we have today for everyone on the Zoom today. We've got everything from asphalt overlays. Now, I would guess that most everybody knows quite a bit about asphalt overlays. It's a primary tool we use in local governments and really everywhere for that matter. So we're going to kind of focus more on warm mix since that's a little bit newer technology. And then we'll go into the hot and cold in place recycling technologies. And for those of you who are paying attention, full depth reclamation, which is not typically considered pavement preservation, but we're going to talk a little bit about it anyway. So without further ado, let's hop in. Oxidation takes its toll. This is one of the things that we learned obviously in module 3, where we talked about top of the curve pavement preservation. And so, these are very effective ways to deal with some of the oxidation. However, when we can't catch it early, these next 4 tools are great to rehab roads cost effectively and in essence put us back on an equal footing when we've lost the initiative by not doing enough on the top of the curve. So without further ado, for those of you who may recall, we had the first of these costs kind of 1 through 6. And now what we're focused on is kind of what I would consider mid to bottom of the curve, everywhere from, we did cover Cape Seal actually on the other one, but we're really looking at thin overlay and below. And so we'll discuss this. Some of these costs will need to be increased because we've had a pretty substantial marker on the old inflation print. So without further ado, let's get into poll question number 1 for my section. Okay, so which type of process are you most familiar with? Let's start that, see what we got. All right, I'll give you a few more seconds. I'm rooting for somebody to hit cold in place recycling. Poor cold folks are in the cold. Okay, I'm going to shut it off now. We'll keep on moving. Okay, so as we can see, we've got pretty equal full depth reclamation, which is actually, again, not really a preservation technique, but it wins with 41%. And then we got tied for 29% at warm mix and hot in place recycling. So cold in place, everyone on this call is going to get more familiar with cold in place. So pretty exciting. All right, let's get back to it. And starting with asphalt overlays, there's a couple different strategies. We're going to kind of cover real quick some thin overlays, kind of intro, and then talk about bonded wearing course briefly and warm mix asphalt. But if we look at thin overlays, that is really that traditional overlay process. It can be with or without milling. And the thicknesses range, as far as what we would consider strictly preservation style overlay, can be anywhere from, using kind of that 4.75 millimeter. Sometimes there'll be some more of the super pave 9.5 or 12.5. But these are really designed for use on pavements that are in good condition or structurally sound base wise. And so there's some different types, obviously conventional dense graded, and then you've got open graded friction course and stone matrix, as well, SMAs. So in addition, we have something called the ultra thin bonded wearing course. Now, this, if you're familiar with the EDC 6, I think it's 6, 5 or 6, they all run together. I think it's 6. But anyway, if you're familiar with that, this is actually on the current Everyday Accounts initiative. And it is listed as really one of those techniques. This is an old picture from back in the early 2000s on a project I was on. And that it used to be called Nova Chip back in the day. In this picture it is. And so it really uses a gap graded polymer modified HMA on this polymer modified tack coat. It's a single pass treatment, and the thickness really ranges from 3/4 inch to 2 inches. And it's really intended to address, some of the surface distress and friction issues, in addition to some, light raveling, those types of things. And this is what happens if you step in it. It's highly polymer modified, the tack coat is. definitely don't want to stick to the road. This is a picture that I took back in 2001, and you can see this material kind of wicking over a concrete pavement. And I would kind of equate it to the rubber band effect. So it's an SB styrene butadiene block copolymer. It sprays very easily, cures quickly because the hot asphalt is placed over the top of the emulsion, and obviously has a lot of superior bonding and qualities to that as well. And then you can read the rest. We've got reductions in noise and back spray because it is open graded. It's great on friction. And this is what it looks like when you're looking down at the spray bar in the back of the paver. So here's where the asphalt is being placed onto the mat, and then you have the screed back here. But right in front of that is a spray bar, which is variable width, and it's spray applying this polymer modified tack coat. So it's, in essence, that's where the preservation comes in, is it's in essence sealing the existing pavement. This would be akin almost to a rubber membrane interlayer, for instance. And so this hot asphalt helps break the emulsion very quickly, and it improves the bond strength. So here's like a little slide here on that. You can see the membrane, the nominal mix size, and the total depth of a standard mix. And that emulsion wicks up around those aggregates. And so because you have greater micron coating on the mix, on the aggregate, then it's going to extend the life of the asphalt overlay. And here you have it again. So you can see now, it should be black, but this little section here is now cured and adhering to the existing pavement. Now, this is a project that I was on back in the early days. And this is a concrete pavement, very old concrete pavement in Florida near Orlando. And you can see that as we were placing this pavement on the jointed concrete, it was crack sealed first. It's very quick. And for something that's normally not done, meaning we don't usually do very thin overlays on top of concrete because of the fear of delamination, this is very effective. We completed the project, or the section, the test section, in less than a couple hours. And typically you would have a lot of cracking come back through this at less than 1 inch. But you can see here through the ages where I've been able to kind of follow this same joint here, is you can see just how effective it's been. I actually was out there, I didn't get a picture of it, but I was out there in 2020, and it still looks very good. It looks about like this. So we're going on over 23 years now. So moving over to warm mix asphalt, that's really the term, and you probably are hearing more and more of this, especially as we get into what you're seeing with the emphasis on green technologies. Warm mix definitely qualifies, and this is a generic technology that allows asphalt producers to produce the mix at lower temperatures, and there's some benefits to that. I won't spend a ton of time. There's multiple different types of additives or technologies, and they each have some different requirements. Foamed asphalt requires special equipment at the plant. But if you look at the components, you have obviously the asphalt binder and aggregate, and then you could have wrap or raz, and then the additives. If it's a chemical additive or anistrip, polymers, those types of things. And you add all those things together and you get warm mix asphalt, which is typically produced at much lower temperatures, meaning less greenhouse gas emissions, less fuel burned at the asphalt plant. So if you look at the advantages, this is a great picture, and I've seen this myself in person, how much less emissions and smoke and issues resulting from warm mix versus hot mix. And so you can just see that right there in at the project. And because of that, we're able to replace some of the things that go into standard hot mix, like lime or liquid anistrip, because some of this chemistry is actually also a liquid anistrip. So the nice thing about this is because we're elevating the temperature lower, meaning we're not heating the binder up as hot, and asphalt binder is very sensitive to temperatures, to high temperatures. It means that we have a longer binder life. We can increase wrap, extend the season, longer haul, obviously the green benefit. And so, here's kind of a little schematic of the types of states that use this. And so if you look at Missouri being a liquid anistrip only, it's not a lime state. So that means that in essence, you're getting some of these chemical additives already. And so here I've got some information from the National Center for Asphalt Technology, or the NCAT test track there at Auburn. And so you can see in this instance, the technology they tested was Evotherm, which is a chemical additive. And you can see the temperature and basically the results. So you can see here's the compaction temperature, and then we have the percent density. The blue meaning the percent density of the cold or the warm mix, and the red being the density for the hot mix. So you can see at the temperature here at about, looks like about 310. Then we had lower densities versus the warm mix at about 230 had much higher densities. Same thing across here. And you can see for PG 76-22, we didn't even use, in this instance, didn't even use a hot mix technology. It just went straight to warm mix. So it's counterintuitive. Most people think the hotter the better, but we need to change that mindset and really look elsewhere. So just as we talked about in Module 3, the maltines or the light ends, those are the four components that make up the maltines versus the asphaltenes in the asphalt binder. This is also helping us with warm mix because less of these maltine fractions oxidize, volatilize, and leave the asphalt under the hotter conditions or cooler conditions. So in this instance, this again with NCAT, you saw this reduced oxidation with the warm mix technology here. And so that equates to obviously a longer binder life after 2 years. So increased wrap usage obviously can save money. We won't spend a ton of time on this, but increased wrap obviously makes the warm mix more cost effective. And we can achieve these savings and include more wrap because of the lower temperatures and still being able to get good quality density of this mix with higher wrap percentages. So this is another kind of schematic. I borrowed this from PaveCool, which is a program that calculates the amount of time that you have as far as cooling and really helps as far as compaction. And you can see that hot mix, especially this time of year, late season paving or early season paving, hot mix only has 19 minutes of paving until minimum compaction temp is reached. And then if you look down here for warm mix, you get a much longer time frame. So with warm mix, you're extending that time frame. You can, as much as double the amount of time that you have. Densities can even be achieved under 200 degrees. Pave in the snow, no problem. I don't know about that, but certainly I've seen snow on the side of projects, and there's ice hanging off of the rollers, and they're still able to do it. So let's get queue up poll question number 2. $325. I like it around 300. Warm, 275. But let's do 250. Let's just see what you guys all like here. See what everybody likes. Oh, I've got one piping hot. There's always an old school piping hot figure, and somebody on the bottom of the curve here, 250. So let's see. Give you maybe 1 or 2 more seconds. And I will end the poll. All right, so it looks like most everybody likes that 325. This is what I've seen here in Florida, at least, is that's the most common. And so you have places like the Keys where we have to ship it further. And back in the day, contractors used to, the only way they could do that is to elevate the temperature of the mix. The problem was that that means that the mix cools even faster. And so it really doesn't end up working as far as being able to go long distances, haul it. And this is why. So if you look at this This is a kind of a graphic showing thermal segregation, what we run into. A hot load, hot part of the load, cold part of the load. And you can see this by looking at this is as the paver's going down the road. So this would be the right after, and this is at the end of the load. Same thing here, beginning of the load, new load or end of the old load, and then a new load again. Same thing here. So the difference in new load versus the end of the old load or the cold part of the load can be as much as 62 degrees. Whereas with warm mix, because of the thermodynamics of the material and the fact that the cooler it is, the less rapidly it continues to cool, then we have a much lower delta between the beginning of the load and the end of the load. And there's a definite advantage to that. So typically you can see load segregation, thermal segregation, meaning this part of the pavement wears out at a different rate than this part of the pavement, and that's decreased. The other thing is that the hotter you have the aggregate, the more absorptive it can become. So asphalt contractors have figured this out, and so they can actually reduce by maybe a few tenths of a percentage the amount of asphalt binder required to achieve the same results. So you can see in this core, we have, hot mix and then warm mix, which is really fascinating. Obviously much greener. If you looked at a tunnel with hot mix, it'd be full of smoke. So stack emissions test. I've talked to asphalt contractors here in Florida where when they're running a stack test for pollutants, they run warm mix. So make sure they run it because they get much better results. So let's do a poll question number 3 here, and then we'll hop into the next segment. Which advantage of warm mix asphalt is most valuable to you? For those of you who are using it or have used it, let's go ahead and see what you chose as the highest value. I'm interested since this is Missouri, so we'll see what everybody comes up with. All right, we'll do about 10 more seconds. All right, let me wrap this up and share the results. So as you can see, it's kind of a mixed bag. We have longer binder life, which I'm excited to see. And then we have improved compaction, better density. In some ways, that also can be shared with that extended season, longer hauls, because you're getting, these better densities in longer, hauls, and actually giving yourself the ability to go a little bit later into the season, which I imagine everybody's trying to do. And then finally, lower emissions. So we will go to the next section here, and performance. If you look at this, I've seen this personally in instances where a test strip, you have hot mix and the warm mix. And so you can see the color difference between hot and warm, and that really lends more credibility to the fact that you've got higher volatilization and kind of the maltines going up to heaven in the form of emissions, versus here with the warm mix at lower temperatures, more of the binder is left, which is going to translate to this next side over here, this other picture, where you have more cracking because you have less of the maltine fractions or the same fractions we use for asphalt rejuvenation, for instance. So if you look at this side, this is the warm mix side versus the hot mix side. So then overlay, I think I might wait till the end. I'll tell you what, if you guys have some questions, put them in the chat, and we'll maybe pop in and see them and kind of field those, but I think I'll keep going. But if you look at it, the really important thing that we want to remember with any of the asphalts is you don't have to look at asphalt as old technology. There's new advancements, and there's certainly a lot of different ways to preserve the asphalt as it's going down, meaning if we use higher quality pavements in the beginning, then that pavement will last longer. in the end. So, okay, we'll dive right into hot in place recycling, try to keep this train moving, pun intended. This is a serious train right here. These are preheaters. You can see just how many they have stretched along here. And this is a process that is really fun to see if you haven't seen it take place. And there's really primarily 3 hot in place recycling, I would say, techniques. And that would be the surface recycling. And so you have kind of the most distressed considerations here, meaning you got to be very careful because this is really just dealing with the surface and not mixing in or repaving any virgin mix, that we're really paying attention to that. And you can see this with this era slide where you can see what surface recycling can address versus what remixing and repaving. And you can see the black is the less appropriate section as far as the distress related conditions. So what kinds of distresses can hot in place address? Well, here's a few slides actually, and it's important to make a distinction of what's causing these cracks. So coring is recommended in any of these in-place recycling techniques. We want to make sure that this isn't a base related, that this is more of a surface asphalt situation. Here's a picture of a phone over a crack. And then here's another issue, here with the pavement. This could be a widened road, it kind of looks like, as you have this outside, kind of in between a wheel pass all the way out to the edge of pavement. So let's do another poll question. Number 4, we're keeping you guys on your toes. All right, what type of pavement distresses can hot in place recycling address? This is a little pre-screening to see how familiar you are with the types of distresses that can be addressed. And we'll see there might be something to trip you up a little bit here. And we'll see what you come up with. When in doubt, everybody always goes for all of the above. Let's see what happens here. Give you a few more seconds. Okay, I'm going to share the results. So it looks like most folks think all of the above. And while that might be appealing, there's one thing that we have to watch out for. There should be a little asterisk here, fatigue cracking. Some of the pictures that I showed kind of what looked like a fatigue cracking issue. We have to make sure when we're using hot in place that the base is not the cause of kind of those alligator crack, patterns in the pavement. And it also depends on, with that poll question, on which type of hot in place recycling technique or strategy you're using. So with surface recycling, you can see here, we're really focusing on heating, reworking, and rejuvenating that top 1 to 2 inches of an existing pavement. And we might be doing that in preparation of something else, or it could be that we're leaving it as such as the riding surface, depending on traffic levels. And so for that process, just a brief introduction. You want to heat the pavement to about 275 degrees, and then basically you're going to try to scarify the material, the heated material, to a depth of about 1 inch. And then that scarified material is then compacted. The recycled lift is overlaid. So if you look at it here, we're compacting this recycled material for the surface recycling. Now, one thing to note is this is typically, because we're penetrating down about 1 inch, this is typically why we put some sort of other surface treatment on the top, because in essence, this is recycled material, and it might be good if you look at the longevity of the pavement to really look at another overlay or maybe a micro slurry chip seal over the top. And this would be an area that we use for more of a rural condition. You can see from these 2 slides, very rural environment here. Could be in my home state of Kansas for that matter. So talking about remixing, this is really, probably getting to be These next two more frequently used than just surface recycling around the country. And this is where we're heating, reworking, and rejuvenating the top 1 to 2 inches and adding virgin aggregate and mixing virgin mix and mixing that in with the newly recycled material in a pug mill, and then laying that. So either as a binder or a surface course. And so this is a common type of an approach and one that we see. Now, it does share kind of similarities to the next process that we have. I'm going to show a little film from Sedgwick County over in Kansas, my home county, if you will. I was able to find this, so let me cue this up and see if this works.
There's no sound, Chris.
Oh, there's no sound? Okay, this happens sometimes. Okay, that's okay. So I'm going to, I don't know why I can hear it. So we'll just mute that and you guys can kind of see what's going on here. Thank you, Larry. And so what you can see here is that they're basically using a process, a hot in place recycling that's going to remove the distressed, old oxidized pavement, and then hot in place recycle that. This specific strategy is repaving. Continuous process with the self-contained train. This is what's happening. You're heating the surface. You've got heated pavement milled, and then obviously we're able to inject emulsion per the mix design, mix and use a windrow and placing the recycled material by the paver and then compacting that. So as with any of these, the preheaters are key. And that's why you saw that slide where it showed just, looks like, a handful of preheaters in front. Here's the windrow you can see. And you windrow this material from under the tunnel heater, and that the heat is transferred into the underlying pavement and into the windrow. And so this is a very effective way to do it. And the nice thing is that windrowed material, 100% of it is recycled material, and it's picked up and paved with that conventional paver. And then the recycled asphalt is placed with the paver. And then you've got now a blended recycled material that's compacted with conventional rollers. So this final strategy is called repaving, and repaving is different from remixing in that we're heating, reworking, and rejuvenating the top 1 inch of an existing pavement, and simultaneously, as you can see from this, we have 2 screeds simultaneously placing the virgin mix over the recycled mix. So here is the recycled material, here is the virgin material. And so that's the distinction. And it has some distinct differences as well. You're using, in this instance, this preheater is using hot air instead of traditional burners. And the train is scarifying, adding a recycling agent, and then laying the recycled material. And like you saw, the train actually has 2 screeds. So the final lift is always new. In this repaving process, it's always new asphalt. So as far as close-ups of the liquid additive system, you can see that right here. The rejuvenating agent is added. You can see the scarifier, and then right over here, there is the tines for the scarifiers. And they're air actuated, so they'll pop up if it comes in contact with a manhole or other utility. So, and actually this is interesting because we're gonna kind of combine the first part with the second part, where warm mix technology has actually been used in the final lift through a recycling train. And so that's pretty interesting. And here, as you would expect here from the FPPC, I'm using an example from actually from Florida. But this is actually recently taken a picture of West Shore Boulevard, and this was repaved in 1997. So very, very good long-term results with these processes. So let's go ahead and hit poll question number 5. All right. Which of these choices is not a real type of hot in place? Let's see what you guys come up with here. Guys and gals, of course. I promise not to tell any of the hot in place recycling contractors who is answering with one of these others. Okay, see, it's an anonymous poll, so you guys are all safe here. I'll give it a few more seconds. All right, let's share the results. Here we go. We have a smattering of surface recycling, remixing, and repaving. And I will tell you what the trick is. This is scarification is the correct answer. Repaving, I'm going to have to rework my question because I realize now if I'm looking at it from perspective of the attendee, repaving could be considered like resurfacing. But if you look at hot in place, the most common are surface recycling, remixing, and repaving. So anywho, we'll keep on trucking. Okay, I'm going to take all these at the end just to make it easy. So, but if you do have something, drop it in the chat, and that way we can kind of get to that. But we'll keep trucking and making headway. So as we move in, we're going to get into the cold in place recycling section. And when we talk about cold, just want to make clear that cold means ambient. It doesn't mean like cold like your beer. It means that we're not having to introduce heat. And a lot of people ask that question because they see this cold in place recycling train and they see this what looks like hot, steam or smoke. And this is actually not smoke from heating in the process. It's friction of the mill cutting into that asphalt. So the purpose again is to remove the cracking network. What we want to try to do is penetrate down into the cracked pavement and pull that material up, remove that crack, introduce an asphalt emulsion most commonly, and then basically take the second stage conveyor and move that back to a traditional paver where we then place the material cold. So, all right, CIR or FDR, easy to mistake the two. A couple yogi quotes that I love, but if you look at it, right turn only. But if you look at it, there are very serious similarities, and this has gotten harder over the years to determine the differences. So we'll get into a little bit of that, but I want you to keep in mind of that because I saw a lot of people are familiar with FDR in Missouri, but they're not as familiar with cold in place. We're going to get into that. But just so you know, here is cold in place recycling, a definition. And I spent a lot of my career in the cold in place arena. And so this is kind of the difficulty. With cold in place, we're recycling the deteriorated asphalt pavement, and it's really reached the end of its life cycle. This is something we typically would mill up and haul back to the asphalt plant and reuse as wrap in new mix. But instead, if you can imagine, we're actually going to recycle it in place. And the typical depths are anywhere from 3 to 6 inches. I would say 5 inches is the most common. And the milling machine is going to cut and size that old asphalt. The material's then mixed with asphalt emulsion and then paver laid and compacted to the depth that is required. And so this is a great shot of the train. So you have the emulsion tanker, you have the recycling train here. This is a single unit train. And then you have the standard asphalt paver. So what it is very effective at is being a rehab strategy which can save a tremendous amount of money, can be up to 50% of traditional reconstruction costs. and it also is very fast compared to remove and replace. In this instance, this is in near St. Augustine, actually. And funny enough, the story behind this road, we didn't know this at first, but there was an old brick road down the middle of this roadway here that had just been overlaid and then widening. And so we discovered it when we were cutting through this road with the mill. We got into those bricks, caused a ruckus, as they say. So this is recycled material. That's how effective this material can be once you've compacted it. You can see this looks very dark, looks great. It is an asphaltic base material in essence, and then capped with an asphalt overlay. In this instance, this client actually widened the pavement by using the excess asphalt here, and then pulling and laying the width of the pavement all the way out full width. So there was no joint here where you would have a traditional joint for widening. So as far as what kinds of distresses we can deal with in cold in place recycling, you can see the whole gamut. The distresses often extend full depth. And so there's a lot of capabilities with this process. The deeper we go, however, the more expensive it is. So let's talk about poll question number 6 real fast. Okay, what is the most common additive used in? This is actually, I made quick mention of it, but let's see if everybody caught that. What is the most common additive used in cold in place recycling? A few more seconds. All right, so asphalt emulsion, that is correct, at least in many of the states that I've been around. You can use lime cement or fly ash. Typically though, the hybridized kind of system is to use asphalt emulsion and cement. So again, no one here is wrong because they didn't put none, but as far as the most common, you could expect to see asphalt emulsion for cold in place recycling. So on to the benefits of cold in place. Really what I think people are gravitating towards CIR with as many demands as we have from the traveling public to get in, get out, and stay out, is we really love the fact that, or they love the fact that the road remains open during construction. You get a lot of good production when compared to traditional reconstruction or rehabilitation. There's also reduced impact. If you can imagine, we'd be removing all of this asphalt and hauling it off. And so we would actually be impacting adjacent roads by hauling thousands of tons of wrap over those roads. Obviously, we've already talked about the reduction in cost. Always best to reuse existing materials, and the fact that we can reprofile the pavement, the road, runway, whatever you're doing is beneficial as well. And really it gets down to removing the cracking network. That's what we have to do. If we leave the cracks intact, those cracks are going to revisit us in the future. And that's problematic. So what does a candidate look like? Here is a good shot. You'll recall some of the pictures that you saw from the hot in place. Sometimes the roads look very similar. And so you might see any of these types of deficiencies in the pavement. And then really what we try to do with cold in place recycling is we need to know what the extent of the distresses are, meaning what depth are they occurring, what the condition of the base is, because again, we're just recycling the asphaltic material on top of the base. And so then what we're really worrying about is how deep do those cracks penetrate and what's underneath it maybe causing these cracks. So you can use single or multi-unit trains, and they're going to pulverize, mix, and then lay the asphaltic base course. And then, of course, the process goes that we're going to compact that mix. We're going to be using a steel wheel and a rubber tire roller. And that rubber tire roller is quite heavy if you look at that 27-ton rubber tire roller. And that is because oftentimes we're compacting, thicker lifts. So And then, yeah, warm mix asphalt could do that. Put it on the surface. Okay, let's do another poll question. Okay, how many inches is the most common for a cold in place recycling project? 2, 3, 4, 5, 8. See what everybody comes up with. Most common depth for a CIR project. All right, let's share the results. Okay, so we have no one at 8 inches. That's good. So I would say, the 5-inch folks have it here at 47%. Keep in mind, we can do between 3 and 6 inches. 4 to 5 inches are typical. That's the most common. 2 inches, the problem with that is that the cold in place gradation that you're going to be left with, you're going to have some 2-inch material potentially in there. Because of the way that it crushes the recycled material. So that's why we typically are going to see 3 to 5, 3 to 6 inches. So we will keep on trucking. Okay. Now, again, I made a little bit of a mention of this, but road widening can take place in front of the CIR, either if you're, have material that you're incorporating, or you can actually remove vegetation and then compact the remaining sub base and then put the asphaltic base right over this in more rural instances, and then put asphalt overlay over the top of that. So again, compaction is key. We have the need for a big pneumatic tire roller because we're compacting thicker lifts, and then you've got the preceding and following steel wheel. And without heat, the weight of the rollers and the rolling pattern is very critical. And some contractors even utilize high density pavers that are getting compaction behind the actual screed. So that's pretty interesting as well. So, and it's always capped with the surface course. After the base material cures, we do leave this base material open while the moisture, kind of evaporates out of the mix. And then we cap it. And when you do a really good job, you get what you have on one of my favorite cold in place projects located not far from my current location. And they went ahead and painted a drag strip out. This is like a 10-mile stretch and it's perfect. So as soon as we saw this finish line painted, we alerted local authorities and let them know they might be able to catch Vin Diesel out there at some point. So. All right, question and answer. Again, we'll wait till the very end and see what we can come up with. But a couple good, here's one of my favorite Paul Bear Bryant quotes. So let's dive into the bonus round, and then we'll kind of go into some Q&A and some wrap up. But FDR, now again, many of the definitions that we've talked about come from the Asphalt Reclaiming and Recycling Association, and I encourage you to look for the Basic Asphalt Recycling Manual, or the BARM. They've got some excellent data in there, a lot of good material, and just like when we talked about the ISSA, the International Slurry Surfacing Association, ERA is a great resource for these deeper rehab and recycling technologies. So FDR is considered the red-headed stepchild. It doesn't even belong here, should not be confused with preservation, but it does use some of the same equipment. And so I wanted to include this so I could educate folks on why this is not included in preservation and why it is confused with cold in place. So what is the definition? We need to know. It is a rehab technique in which the full flexible pavement or asphalt section and a predetermined portion of the underlying base are uniformly crushed and blended together, resulting in a stabilized base course. And that stabilization is usually obtained by, additives. And we talked about some of those additives cold in place, might be fly ash, lime, cement, typically can use emulsion. And those are the differences from CIR. It's used in different instances or distressed areas than CIR. And one of the primary other differences in equipment is that oftentimes the cutting head operates in the upcut direction versus the downcut. So let's go to poll question number 8, if we would here. All right, what is the biggest difference in CIR and FDR equipment? Some of these we made hard and some of them we made it easier. So let's see what you think. I'm so happy no one's picking the color. That's good news. Okay, let's end the poll. Yes, the milling head direction is one of the biggest differences in CIR and FDR equipment. Now, that said, we've even seen less and less of that be an issue because I've seen FDR using cold in place recycling equipment, and that's in essence what's been going on. You have got to really kind of have a better understanding of what you're trying to accomplish when you're using CIR versus FDR and what depth you're penetrating. So that's what we have to say about that. Let me move to the next section here. Full depth reclamation explained. So if you look at this, this kind of gives you a schematic of what we're talking about, FDR versus CIR and some of the things that we look at. So if you look at the base and sub-base, we want to know what's going on down here in the base, sub-base, subgrade, and are the cracks coming from there or not? So that's why oftentimes you'll see the coring be the critical component here. If it's this kind of situation, then we're going to feel pretty comfortable that cold in place might be a good option. So you can see over here, cold in place. However, if we saw cracking, then down into the base, then we'd have to kick this out as a full depth reclamation or a CIR candidate and look more at full depth reclamation. But here's another reason we don't want to just mill and overlay. So if we did a 1.5 inch mill and overlay, the cracks are going to come back up through, and then we're going to have to overlay it again. And what we're building here is a perpetual crack. And so this is why we don't want to go in and just willy-nilly mill and resurface. So what do? We want to core the roadway. We want to look for if there's any base deficiencies, or in this instance, in this picture, you can see a sand clay base, which would indicate we need to do something to stabilize that base. And this is a contributing factor of why the asphalt looked terrible on the surface. So we're going to reclaim the existing pavement and the base, and we're going to use a stabilizing additive. Often it's an asphalt emulsion and or a cement, and oftentimes it could be lime. And we're going to grade, shape, and stabilize the stabilized base, and we're really going to grade that to get the proper cross slope, elevations, those kinds of things. And then we're going to compact the reclaim material and then prime it and pave it. So core equipment in action, you can see reclaimers, graders, additive trucks. We have could have dry additive, could have rollers. We definitely have rollers, water trucks. Here is an instance where we've got the train on one lane and the steel wheel in the other lane. This is actually a runway project. We're doing some fine grading and compacting. Here you can see a cement spreader. Here you can see the cement actually right here. And then this, it could be either water only, or it could be, in this instance, a hybrid approach where we're using asphalt and cement. And then here with this project, hydrating the cement, making sure that we do a good job of grading and compacting, and then we would put a lift of asphalt over the top of that. So some of the benefits of full depth reclamation, again, substantial savings over traditional reconstruction. It's not preservation, but it can be used very effectively when pavements get to the end of their life cycle and we need to rehabilitate them. Also simplify some widening. Again, much like cold in place, you are going to remove the cracking network, and it is going to be quite effective at getting some of the structural numbers up. You can make some longitudinal profile corrections, and there's quite a bit of protection against the soft and yielding in some parts of it. So CIR or FDR? That is the question. There are some of the things we look at. All right, so this is the cold in place recycling, is what you would see. And then this is a standard road reclaimer. And so how do we pick the difference? Well, we're going to look at the survey, look for major adjustments to the profile. That's not going to be something cold in place is as effective with, because again, we're basically milling and then paver laying the recycled material instead of hauling it off to the asphalt plant. And obviously we've already mixed it with emulsion. So we're going to core the road. We're going to look at the depth. We're going to look at the dominant distress. And this is what we're going to do anytime we look at a pavement. Anytime. Look at the dominant distress and try to figure out what is the most cost-effective way that we can address the dominant distress of the pavement. I know we talked about that for those of you who are here for modules 1 and 2. Larry talked a lot about this. I talk about it. We want to really better understand what's going on with the patient. In this instance with FDR and CIR, the patient is on life support. It's pretty beat up. So rather than let the patient die, we use these recycling techniques to go in and deal with it. Now, we also want to look for things like a high water table, because that can be a problem. This is a real road near the swamp in Florida, and it looked like a canal more than a road. But this is what the road looked like after we brought it up and then added cement. In this instance, cement was critical so that we could deal with the high water table. And this is a project that you've seen where once the sand clay was discovered, this project was changed from a cold in place to a full depth reclamation project. So that's one of the key things. So real situations, how they turned out. Here's the canal road. This is in Florida, of course, but this is a primed base. Looks good. Don't have to take a boat down the roadway or down the people's neighborhood anymore. Let's go ahead and get the last poll question, number 9. Everybody's doing a great job. Let's see what we come up with here. All right. Is FDR considered pavement preservation? Yes, no, I have no idea. See what everybody thinks. I suppose if I really thought of it, I'm including it in a pavement preservation seminar. So share results. No, most of you said no, 83%. I think that's the highest percentage of all. For those of you who said yes, that is actually kind of right as well. If you look at FDR, we consider it something that is an alternative to rehabilitating and reconstructing, which is always good. It's officially not included in pavement preservation, like kind of documentation. However, that said, Larry and I talk a lot about it because it is pretty important. So I'm going to stop that, close that. All right. So FDR questions and answers. Again, we're going to talk about this, here towards the very end. I think it'll be easier if we do it that way. So we all have to deal with bad roads, and I'm going to turn this over to Larry here in just a second. But if you looked at some of those sections, at some of those treatments, depending on the road and what's going on with the curve of the road, helps us also identify which road to invest in and which treatment to use. And so when you dip below these terminal thresholds that we've seen before, the strategies we just covered really help you to save the day, because these are going to be much more expensive. And so here's a graphic from PPRA that we've used throughout: right road, right treatment, right time. And all these treatments over the past 2 modules are proven strategies. So don't be afraid to use these. When they're used on the right road at the right time, they're very effective. So my last quote, this is before I turn it over to Larry, is my favorite, and that is, you don't have to be great to get started, but you have to get started to be great. So if all you are using is a hammer, everything looks like a nail. And if all you're using is asphalt, then everything looks like an asphalt candidate. Whereas using a lot of these other strategies are going to be more effective at stretching your dollars. And with the rate of inflation, being, whatever they say it is, which is probably low, 6%, probably closer to 12, 14% in construction. We have to get creative. It's incumbent on all of us to do the best job we can, picking the right road for the right treatment at the right time. So I'm happy to answer any questions. I'm going to kick it over to Larry. I'll stop sharing and let Larry pop in, and then we can open it up a little bit. Larry.
Thanks, Chris. I really haven't got a whole lot more to add, except I just want everybody to realize that with these actual specs, I'm not asking you to go out and adopt them in total if you have a system, but I am asking you to take a look at them and maybe you can improve your existing specifications.
Right there, my friend.
Can you hear?
I can hear you, Larry.
Okay. I'm asking you to go out and improve your existing specification. And so take a look at these, take the time, go out and look at these specifications because it will definitely improve your system. If there's any questions, we'll be happy to try to answer them for you right now. Was there anything in the chat box?
I didn't see anything in the chat box.
Okay, if anybody has any questions, can we open the mic up for them, Christy?
They can just unmute themselves.
Okay, well, if we haven't got any questions, at this point, I think we can probably close this presentation down then.
I mean, there's got to be one. We should literally just start calling on people, Larry. That's how we should do it. What do you think, buddy?
You guys did a great job, and everybody understands what you were talking about. So
that's it. That's a great deal, Mike. Yep. And that's we covered a lot of ground. So if we did that, then
yeah, very thorough. If there aren't any questions, we'll wrap this up. Chris, I'd like to thank you. Larry, I'd like to thank you for presenting and your knowledge. Chris, I'd like to thank you for setting this up for us. And we don't have anything scheduled as of yet for another webinar series, but we are working on that. So if you guys take a look at your email, we will put something in there and let you guys know when we'll be presenting again. So I hope everybody has a good afternoon, and thank you for joining us.
Yes, thank you, Mike, for having us, and we're happy to help any way we can. And we'll look forward to some great content from Missouri in 2022.
Thanks, everybody. I appreciate you guys taking your time out, including us in it as well.
Absolutely.
Thank you, everyone.
Take care, everybody.
Thank you.
Goodbye.